Welcome back. For this lesson, I'm going to show you how to find the surface area of any regular polygon. Regular, of course, means that all the sides are the same length, all the angles are the same, and that it isn't concave. So, by concave, I mean if this were shaped like that, that would be a concave and it wouldn't be regular, even though all the angles and everything would be the same. So, to find the area, the surface area, I guess A would be it, of any regular polygon, a little bigger, you need a few things, one of which we're not really used to looking for, and that's called the apothem. That's the distance from the center to the closest side. I'm going to try to draw a straight line. Great. And that's represented by a lowercase a. So that's sometimes tricky to find. Like if you're given, I'll draw another straight line. If you're given a different distance, like this is called the radius from the center to, that's a straight line, from the center to there, say you were given that is whatever number, then you might have to do Pythagorean theorem on this, and then you would just ignore most of the shape. You would just look at Pac-Man's mouth. You would see that this is a right angle here, and you would just zoom in on this triangle and only focus here. You would say, well, if that's x, whatever number it is, it's a little backwards what I'm saying, this is just any number you happen to have in your book. Then you'd have to find this interior angle, which I'm having trouble drawing. And that's not a mystery because it's an octagon. So then you would say a full circle is 360 degrees. And then you divide that, by 8 because it's an octagon. So that gives you this angle. That gives you that whole thing. And then you would have to divide that again by 2 in order to get this little thing, which is 22.5. 22.5 is that little angle. And then you would just use your trig. You would say, would that be adjacent over hypotenuse, so that would be cosine. But, you know, trig isn't for this lesson. The point is you need to find this distance, this center to the closest part of the shape, or you could say it's perpendicular to the sides. You need to find this little apothem thing, however you need to go about that. And usually the book won't give it to you that easy. It's not just going to say, hey, guess what, this is 2. It's not going to be a nice round number. It'll be more like, you know, that. So once you find the apothem, you'll plug that into this equation. This equation. It's area equals 1/2 times the apothem. And then the last thing that you need to find is the perimeter of this shape. And that, again, might be tricky to find. They might give you some other value. They might give you, that's a 3, and you'll have to multiply it by 16 or whatever. But in this case, well, we know the apothem's 2. I'll just plug that in. So, I didn't make a very good example because it's just 1/2 times 2 times perimeter, and you're going to think it's just perimeter, but trust me, it isn't. If this were a different size, it wouldn't work like that. So to find the perimeter of this thing, we have a 2 here, a 22.5, so it would be tangent of 22.5 equals 2 over x. And we arrange that to x equals 2 over tangent blah blah blah. I don't think this can even do tangent. Well, darn. But that's okay, because we can still plug it in. This is how I like to do math, because I don't like to do a lot of work. I say A equals 1/2, well, 1/2 times 2 you don't even need to write, so area equals 2 divided by tangent blah blah blah. And that's the tangent blah blah blah. So I'm sorry I didn't get you a straight answer, but I don't want to go dig out my calculator. I'm not sure where I even have that. You know, we could just cheat and say it was sized differently. We could say each side is 2, and then it would be 2 times 8, and then you would be able to find it. It would be, well, the apothem would no longer be 2, so then that would be trickier to find. You're not usually going to find a real easy answer. I'm not sure which thing to do to find an easy answer. But that is the formula. That is how you find the thing. So as long as you have the general idea, I don't think it's really important for me to go through with numbers and show you. And with that in mind, I'm going to go over to my next example, the hexagon. I'll delete all this stuff. I like hexagons. They look like honeycomb. That's one good thing. I'm going to rotate this so it's easier. Something like that. Trying to get it as straight as I can. So the nice thing about hexagons, what makes them really great to work with, is that the radius, that's the distance from the center, I forgot my straight line trick, from the center to the corner, is the exact same distance as each one of the sides. You see that? It's a parallelogram. We could prove it using geometry proofs, but you can take my word for it because it's really nice. Also, when we do our little triangle here that we're going to focus on, something really convenient happens again, and that is that this is a 30-60 right triangle, which are very nice to work with. So 30, 60. So we're going to say the apothem is 2. I picked a nice round example. And then to find the perimeter, we're going to need this side anyway, so that's a 1, which means that this whole side is 2, which we already knew because this side is 2. And oh wait, did I do something wrong? Oh yeah, it's not exactly 1, it's a little longer. That's the problem. It's a little bit past the line, that's where I went wrong. Darn. I don't want to work with that. I think I'll resize it. Just gonna cheat so that this is now the square root of 3. Oh, darn. My stuff doesn't go with it. Well, I should have thought this out better, but the point of this is that to find the area of this regular hexagon is in theory very easy because we have a few shortcuts, and it works the exact same way as the last example. It's just 1/2 times the apothem times the perimeter. I can try to explain where this formula comes from. The perimeter is just kind of using the same shortcut we had before. You're kind of splitting it into a whole bunch of little sections is what this formula does. It splits it up into tiny sections, finds the area of each one, and then combines them back again. So the apothem is the straight part. I'm going to switch the color to emphasize here. New layer, blue. Is this what I want? I'm running out of time anyway. Perfect. So So the apothem is this little part, and then, if we find that, then that would give us, or 1/2 times that would give us this triangle, and if we do that times the perimeter instead, then that gives us the entire thing. So it's 1/2 times the width of all the triangles times the height of each individual triangle. That's the apothem. Now I just have a beautiful squiddly thing. But that's how that works. That's where the formula comes from. So hopefully, if your brain locks up on the test and you need to think it out, then you'll be somewhat equipped to come up with the formula on your own. That's my goal, at least. So, thanks again.